Hello and welcome to SmartMe. In this tutorial, we are going to learn how to manually set up test containers in a Spring Boot application. This approach will work for Spring Boot version 3.x, 2.x, and even Reactive Spring Boot applications. Test containers provide disposable Docker containers for databases, message queues, Redis, and so much more. With test containers, we can test our application without mocking the database layer, Redis interaction, and even the RabbitMQ communication. However, unlike the regular JPA library, Spring Boot auto configuration for test containers does not yet support the reactive database connection. The reactive database connections or reactive Spring Boot applications uses the R2DBC library for database interaction. Therefore, we have to configure it manually. I have a simple reactive Spring Boot application here. It has two endpoints for managing a pet resource, a post for creating and a get for retrieving all the created pet record. I have written test cases for the endpoint to guarantee that my application works as expected at all times. Now I'm going to run the test cases to be sure my application is still behaving as expected. These tests are passing because I have my local database running. This is not the best. We need the tests to be able to run independently in a CI/CD pipeline. And we also don't want to mix actual data with test data. So what we need to do is to configure the test to use a Postgres Docker container provided by TestContainers. Our application, by the way, uses Postgres DB. Step one is to ensure that you have a Docker running on your local machine or on any other machine that you are running the code. If you don't have it installed already, please go ahead and do so. Step two, we are going to need to add test container dependencies to our application. I will start by adding the parent BOM dependency. This will help us manage the versions for the different dependencies of test containers that we want to add. Now we can add the individual dependencies to the application. Now that we have the dependency, I'm just going to quickly reload my Maven. While that is going on, the dependencies that I have here, I have added the core test container library, right, as the artifact ID test containers. I have added the JUnit Jupyter extension for test containers. And finally, I have added the Postgres SQL module for test container. Now that we've added the dependencies, let's configure it. So I'm going to open the base Spring Boot application test, right? And I'm going to create an instance of a PostgreSQL container. Now that we have this in place, notice that we pass the Postgres Docker image tag to the constructor. This is how we specify the actual Docker image we desire. Test containers will pull it from Docker up during startup. Now that we have created an instance of the container, we need to override the database connection properties so that it can use the host, port, username, and password of this particular Postgres container that we have just set up. And no better way to override application properties at runtime than using the iDynamic properties annotation. I'm going to just do that at dynamic property source, and I will add the method static void register, just call it register dynamic properties. Right. Now that we have this, we are going to override the data source URL. We are going to do registry.add. Great. What we have done here is to override the Spring R2DBC URL with the hosts, port, and database name of the Postgres container we've created. We've also override the username and password to be the same as that of the container we've just created. By default, test containers will use random ports. But the fact that we have specified that we need it to expose the port 5432, we can use this method, Postgres container.getMappedPort, to get the random port that was mapped for this original port of 5432. Now we are going to start the Postgres container within the register dynamic properties method. This is to ensure that we have a proper start sequence and we don't get unexpected behavior during test run. If we don't start it within the register dynamic properties, sometimes the test might actually require database connection when the container is yet to be up, and we don't want that scenario. It is best to approach it this way. So we're just going to do Postgres container.start. Now that we've started it manually, we are going to add a shutdown hook. So we're going to say runtime.get here. We are just going to do this, add this shutdown hook just to ensure that the containers is shut down upon completion of the test run and all the resources are released and cleaned up accordingly. Now, before I run the test again, another thing that we can do is we can instruct the PostgreSQL container to actually execute an init DB script, right? So how do we do that? We can go to the test resources. We are going to create a new, we can create a file. I'm going to call it init.sql, and I will paste the SQL script I want it to execute in it, right? Then I'm going to go back to the PostgreSQL container. I'm just going to add another, call the function with init script, and I'm going to leave it that way. Whenever test container is starting, this PostgreSQL container is starting, it's going to execute all the DB script that is all the SQL statements in this particular init.sql file that we have set up here. For this to work, remember, this is a reactive Spring Boot application, and PostgreSQL container does not really interact with the R2DBC library. So we need to add the PostgreSQL library, the JPA one, to our code base so that the init script can be executed accurately. So I'm just going to come here, add PostgreSQL right there, and then we have the scope to be limited to test. Now that we have everything set up, I am going to stop my local Postgres server and run the tests again. And voila, the test passed. As you can see, every database interaction is happening with a real database, the real PostgreSQL container that we have set up, right? The beauty of this is that we can use this setup approach for even non-reactive Spring Boot applications, right? And it's going to work. Right now, my application is on Spring Boot 3.x, but 3.4.2, you can use the same setup for Spring Boot 2.x as well. It will still work. In case you want to use test container for a resource that does not have a predefined container class or a predefined module like Postgres or MySQL. For example, let's say we want to do Redis. We can create an instance of generic container class and pass in the Docker image that we want, right? We can then use the with expose port to define the port that we expect to be exposed. Then we can now again go back to the dynamic property source and use that to override the appropriate properties that is required. Let's just go ahead and do that. So we can say for Redis, we can create a generic container here. We import the class. It will have the Docker image name that we want. In this case, we are using Redis latest, right? And then we can go to the dynamic property source, the register dynamic properties method, and then we are going to add registry.add, and that's it. Literally, with this, you are able to use test container to run any Docker image that you want and make it available to your application at runtime. What if I want to connect to the temporary database created by test container or to any other container created by the test container on that test? We can add a breakpoint to any test case, and then we run the test in debug mode, right? This will pause the execution of the test, and during this pause time, we can then go ahead and connect to the container that will have been created by test container, or even inspect it using tools like Docker Desktop. So let's quickly demonstrate that. We can add a breakpoint here. And then we run the test now in debug mode. Once the execution has paused, as it has now, we can go back to the console, go back to the main application. we can look for JDBC to look for the dynamic ports or random port that was created. You can see this one is 50383. I'm just going to use database tool for IntelliJ to connect to it, localhost. I'm going to put 383. The username and password that TestContainer always give is usually test, especially for databases. So we can have here TestContainer demo. That's the name of the application. We can test connection. Okay, I think we get the name wrong. TestContainers demo, and boom, we have been able to connect to the database, right? So we can connect to the database and inspect what it's doing, right? If you have Docker desktop, at this point, you can also open your Docker desktop. You will see all the temporary containers that was created, and you can perform debugging activities before they are disposed, right? So I'm just going to resume the test run, which will, complete the test and dispose the temporary container that was created. If I were to refresh this now, you can see I'm getting an error here that connection refused because the container no longer exists. Can I use a private image? Yes, you can use a private Docker image if you want it. One of the quick ways to do that is first you need to add a new configuration properties here called TestContainer dot properties, TestContainers dot properties, right? And then in it, you can now have up.docker.io, right? I'm using docker.io here because this will be the URL of your private Docker registry. Don't forget that you have to authenticate to your private Docker registry, either if you are using this in your CI/CD pipeline or even on your local machine. On your local machine, you can simply come and run the command like docker login, your private Docker URL. In this case, I'm using docker.io. Then I can do -u username, and then you can do -p Docker password, right? Where Docker pass is the environment variable for your Docker password. That's how you'll be able to use private Docker images for your machine. Finally, don't forget that test containers requirement is that there is a Docker runtime environment, right? So if you are running this, if you want to run this application in your pipeline, you need to make sure that you have Docker available, right? So some CI/CD providers like GitLab, we call it the Docker and Docker service, right? So you have to make sure that you have this available. A good test of this is that in your CI/CD steps, make sure you're able to run Docker --- version. And if that executes successfully, then test container is going to execute, your tests are going to run successfully, and they are going to give you the expected behavior, right, in your CI/CD pipeline. Don't forget, if you are using the private Docker registry containing your private Docker image, or you're using it for mirroring purpose, you need to ensure you log in to it, even in your CI/CD pipeline. The complete source code is available on GitHub, and the link will be in the description below. Thank you for watching. Please like this video and subscribe to my channel for more great tutorials. Until next time, happy coding.